Okay, example 3. All right, so let's read the information, draw in what we know, and then we answer the questions. So it says in the diagram, PQ is a common chord of the two circles. So in other words, PQ forms part of this circle and PQ forms part of the big circle. Okay, now this one's going to be a little bit tricky because there's quite a bit going on. All right, but just like I say, try and stay focused. Using colors will really help. All right, the center M of the larger circle. Now whenever you hear center, your brain starts looking for radii, for diameters, basically any theorem that uses the center. Okay, so in other words, they're saying here, M is the center of this big circle. Okay, it's just a point on the circumference of the smaller circle. So let's go and check out where all the radii are. This will be a radius, PM. This will be a radius, MQ. Are there any more? No. This is a little line. This is part of the smaller circle. It's not anything happening there. Does your brain see this? Do you see this line, right? From M drawn to S, right? Usually, and it kind of looks to me like that's perpendicular, but we'll find out when we get there. But usually if you see a situation like this, right? This is the theorem that you're looking at. You see it's kind of drawn from the center, perpendicular, and then it bisects the line. I have a feeling something like that's going to come up. Let's see, what else do we have here? Okay, so that's everything to do with the center. I also see this over here. Do you see that little angle at center 2 times angle at circumference? Okay. PMNQ is a cyclic quadrilateral. Okay, so let's highlight it. PMNQ. Because the fact that they've told us it's a cyclic quadrilateral is going to help us with a whole lot of things. PMNQ. We know if it's a cyclic quadrilateral, our opposite angles, so this one kind of relates to this one, and they'll add up to 180. And then this one will relate to this one, which will also add up to 180. And then lastly, it's kind of a lesser known or a lesser used one, but there is an exterior angle here. Okay, so don't miss out on this. Do you see this N? It's like extended. So this over here, this exterior angle is equal to the interior opposite. So that will be equal to that one. Are you with me? Okay, so we'll check that out when we get there. In the smaller, it's a cyclic quadrilateral in the smaller circle. QN is produced to R. Okay, so in other words, that touches R, that's fine. A point on the larger circle. NM produced meets chord PR. What are they saying? NM. Okay, that meets S, that's fine. And I don't think there's nothing else that they've already said there. Okay, so we've read it, the words were confusing, but now we've done that. Now, again, search for any other theorems that you can see. I told you I spot this one. This thing. Okay, where essentially this is half the size of that. Angle at center, 2 times angle at circumference. Okay, cool. I think that we've covered everything I can see. There might still be more. So it says, give a reason why N2 is equal to X. Okay, N2 is equal to X. Now do you see? That's that external angle and the cyclic quadrilateral. Okay, so they're just saying give a reason why N2 equals X. So because Y, exterior angles of a cyclic quad are equal. Are you with me? Kind of like doing that saved us the work of doing this. Okay. 3.2. Write down another angle equal in size to x and give a reason. Okay, you might not have seen this, but take a look at the two radii here. The fact that these two lines are equal, what does it do for this triangle? It makes it an isosceles triangle. So which angle here is equal to x? It's going to be Q1. This angle over here, I should have mentioned that when we did the radii, but I didn't see it. But Q1 is equal to P2 because this is an isosceles triangle. So write down another angle equal to x. You can say Q1 equals x. Why? Because base angles are isosceles triangle. Also, please add in, because I actually forgot to write this before, so maybe put this before that, but how did we know that this is an isosceles triangle? How do we know MP equals MQ? Okay, so, sorry, fill this line in before you get there. I'm going to write it here. PM is equal to MQ because radii. Okay, sorry, you must say this before you can say that, because how did you know it was an isosceles triangle? Because PM equals MQ because they are both radii. Okay, all right, so make sure you put this in before this line. All right, 3.3. Determine the size of R in terms of x. Okay, so I want you just to note, we discovered that is x. We discovered that is x. Okay. Now, they just want it in terms of x. Is there any theorem that I have actually drawn in there that's to do with R? It will be this little pink one. This angle at center is 2 times angle at circumference. Also, do you see that M1, this thing, is part of a triangle? So I could very easily get M1 just by using some angles of a triangle. Then once I have M1, I know that M1 is double the size of R. You with me? So that's what we could do to find that out. So we're going to say angle M1 is equal to 180 degrees minus x, which is minus 2x, because some angles of a triangle. All right. And then we know that angle R is half the size of this. So it's 180 minus 2x over 2, because the angle at center equals 2 times angle at circumference. So the circumference is half the size of the center. So angle R, if I work this out, is just going to be 90 minus x. So that's what we have worked out there. This is 90 minus x degrees. Okay. Lastly, prove that PS is equal to SR. Okay, prove that. So what they want is this one. We must prove that that one is equal to that one. Now remember I said earlier, this to me looks like theorem 1. So remember theorem 1 had 2 little situations going on. If you draw a line from the center perpendicular to the chord, then you're saying, hey, this thing is bisected. And if you draw a line to the midpoint without saying 90 degrees, then you're proving that it's perpendicular. In this case, we're trying to prove that it's bisected. So if I can go and show that this angle is 90 degrees, then I can say, therefore, those 2 lines are equal because line drawn from center perpendicular to chord. I've proven that that's 90, so therefore I've proven that those 2 sides are equal. Alright, so let's look at angle S1 and S2. Is there any way that we could figure out what either one of those are? Okay, I'm not going to lie, on this side, there's very little information. So I know this is X, but it's in this triangle. It's like there's not much I can do there. However, if you look over here, you've just worked out r is 90 minus x. You also know this is x, and this is a triangle. So I could use 180 minus this minus that. And also a subtle hint is that the questions that ask you are usually in that order for a reason. So 3.4 comes after 3.3, and they've just made you work out r. So sometimes it's a good hint. You almost know that how you're going to work this out is using the previous answer. Okay, so 3.4, angle S2, we're going to say is 180 minus x minus, put it in a bracket so you can sort out the signs nicely, minus 90 minus x, because sum angles of a triangle. Alright, so angle S2 is 180 minus, so it becomes 180 minus x minus 90, and then plus x. So angle S2 is 180 minus 90 is 90. Minus x plus x, what happens? They just cancel each other out. So do you see how this turned out to be 90 degrees? So I've proven that a line drawn from the center is perpendicular to this angle, or that's a 90 degree angle. So if it's perpendicular, it will bisect. So I can say, therefore, what they asked us was prove that PS equals SR. Therefore, PS equals SR. Why? Because line drawn from center perpendicular to chord. Okay, I hope that makes sense. It is quite a challenging one. Yeah, take a second to write that one down. All right, last but not least, another difficult example. Example 4. Okay, so by the way, after this now, I'm going to send you guys some exam questions to try on your own, and I'll post the solutions in the group, and then you can check if you understand correctly, and then Wednesday we will have that assessment on Euclidean geometry. All right, so example 4. Let's start as we have been by highlighting all the information. In the diagram, M is the center of the circle. Okay, cool. So again, before we start, I'm going to check what my different radii are. Okay, so here's M and your little circle. They've actually already put 2 lines there for MN and LK. So whatever radius or radii I pick out, it's also going to have one of these little double lines. It's going to be the same size as this and the same size as that. So let's see. So here's one, MP. Okay, here's this little one is here. So here's one over here, and then over here, ML. Okay, so those are all radii, and I'm actually going to make this pink, and I'm going to make that pink just so I can see it nicely. All right, there's no, oh, there is a diameter. Here's a diameter. It doesn't, or does it subtend? Let's just highlight it anyways. So here is our diameter, and I do actually see an angle here and an angle there, but it's not subtended. You know, it doesn't make that semicircle situation. All right. Passes through points L, N, and P. That's fine. That's just saying that the circle passes through those points. PM is produced to K. So where's PM? PM is produced to K. Okay, in other words, it goes all the way through to K. That's fine. KLMN is a cyclic quadrilateral. Now that's important, so let's highlight it. KLMN here. And you can actually see it's a cyclic quadrilateral because it falls on all the points of the circumference there. And remember, if something is a cyclic quadrilateral, you already know what's happening. These angles are supplementary, and these angles are also supplementary. I don't see any external angles. Remember, external angles, like if this is the line, it would have to continue straight, and then it would be like an external. This isn't external because it's crooked. Okay. Alright, so that's an external, that's a cyclic quad, so we know the opposite angles are supplementary. KL is equal to MN, we've already seen that. LP is joined. Okay, that's fine. And KML is 20. Alright, so we know that this one over here, I'm just going to color it in purple all the way. This one is 20 degrees. Alright, now let's answer questions. I don't see any theorems right now. Let's have a good look. I do notice that you see these two lines are equal, KL and NM. And if I get this page to show you, we've had this situation before. Let me see if I can find it. Here we go. Remember I showed you this at the start of the video. If something extends from a different place, but it has the same length, like this one goes from here to here, and this one goes from there to there, but these two sides are equal to each other, then the angles are equal. So I can say for sure that this is the same length, that it subtends that angle. This is the same length, so this angle K1 is going to have to be the same as the purple one, because it's subtended in the same circle by the same size chord. Okay, I know that sounds a bit confusing, but if you are confused by it, go back to one of those earlier videos that I made on that theorem. Okay, write down with reason the size of NKM. Okay, funny enough, they just asked about what I was explaining now. NKM, they want this pink one. Now I can say for sure that K1, NKM, is equal to 20. Why? It's subtended by the same sized chord. This is just like a rearrangement of the bow tie situation. Remember the bow tie situation looks like this? And the reason it works is because if this is a chord here, this chord subtends that angle, and this chord subtends that angle. But sometimes the chord can be placed in a different area. So this chord subtends, and the chord is the exact same size, also subtends. Okay, so remember, what is this called? Angles in same segment. So I can say, so 4.1 NKM is equal to 20, because angles in same segment. Alright. Okay, 4.2. Give a reason why KN is parallel to LM. So they're talking about this line LM parallel to KN. Okay, so we established this is also 20. Do you see anything going on here about parallel lines? If I've proven, what was that Z shape? Do you guys remember what that Z shape is called when it looks like this? This is alternate angles. So if I've proven that those two angles are equal to each other, therefore the line should also be equal. Okay, so I can say LM is parallel to KN. Why? Because alternate angles are equal. I've proven that these alternate angles are equal, so it forms that alternate shape, and LM will be parallel to KN. Alright, 4.3, we are almost there. Prove that KL is equal to LM. Here's KL and here's LM. Now you can't actually see it because I colored over it in purple, but remember earlier we did the radar thing, and I said this is a radar, this is a radar, this is a radar. So all three of those are equal. This LM is equal to NM. But we also know that NM is equal to KL because they gave it to us. So if I say LM equals MN, which equals KL, why? Because radar. Okay, so that's what I'm going to do. I'm going to say Lm is equal to Nm because radar. Okay, so these two lines are equal, but Nm equals KL. So I can say, therefore, Lm equals KL because it was given to us. They told us that those two lines are equal. So therefore, if this one equals this one and this one equals this one must be equal to that one. Okay, 4.4, we are on the last question, guys. Calculate with reasons the size of KNM. KNM. Alright, so they want this angle over here. Okay, this actually took me a second. I had to pause the video and try and figure it out. So yeah, as I've said before, guys, it takes a while to see these things sometimes. So don't panic in an exam if you don't. Okay, so if you have a look here, KL and LM, we discovered that they're the same length, right? Because all three of these lines are the same. That's what we worked out in the previous question. So do you agree with me? Starting to look like a Christmas tree going on here. Okay, so do you agree with me? This is a triangle, and because these two sides are equal, these two angles must be equal because it would be an isosceles triangle. So this would also be 20, right? Just follow my line of thought here. That would also be 20 because it's the base angles of an isosceles triangle. Then we could calculate this L2 over here because it would be 180 minus 20 minus 20, which would give us the L2 angle. And then we know that this is this is a cyclic quad. So angle N would be 180 minus whatever I get for L2. Okay, does that make sense? All right, so let's do that. Let's go say angle L2 is equal to, or first, before we even do that, how did we know K2 was 20? So first I'm going to say angle K2 is equal to 20 because base angles isosceles triangle. You don't need to state that LM equals KL because we basically did that in the previous question. Okay, so now we know K2 is 20, so therefore angle L2 is equal to 180 minus 20 minus 20 because sum angles of a triangle. Okay, all right, then so this is going to be 140 degrees. All right, then lastly, to get angle N1, we can say it's 180 minus 140 because those two angles are supplementary. So you can say opposite angles of a cyclic quad are supplementary. So angle N1 is equal to 40 degrees. All right, guys, I hope that makes sense. It was a bit of a confusing one, but that's the point. You're going to get difficult ones and you're going to get easy ones. Usually in the exam, they put one simple one and one difficult one. So as long as you understand this example, you should understand what is going on. The only thing I didn't see in any of these examples was the tan chord theorem, which is quite tricky. So I might try and find you guys an example of tan chord and then post that. But otherwise, I hope that you guys understand. And please, again, WhatsApp me if you have any questions.